at the top. Okay, here we go. Recording, great. It's being all laggy. I'll let it catch up, hopefully. Boop, boop. Okay. So, oh yeah, I cut last day short because my throat wasn't good and I was thinking it'd be better today. It's not really, so here we are. We'll do some quick review, right? And like I said, if you haven't picked up your test yet, but I think all of you guys have your test, so, but if you haven't yet, you can grab it after class. But let's do a tiny bit of review and then we'll do an example as review. Okay? It's going to be bigger than what we did last day, so it's kind of like a continuation / review example. Weird. So we started talking about simple interest. Ultra echoey today. They're like really loud. Anyways, we talked about simple interest, right? And then we developed two formulas. We talked about I equals PRT, where I is the amount of interest, right? P is the principal investment, right? How much did you put into the bank or how much did you take out? R is the rate, right? The annual rate, the yearly rate, and T is time in years. And then we also talked about the future value is P times 1 plus RT. And so we solved problems for future value, for the future value, and P so far. Today we're going to work our way through just how do we solve for R and then how do we solve for T, right? Same old, just kind of working this formula all the ways that we possibly can. Any questions before we start this example? So we'll do example 147. Mostly because I think it's really fun to say. Okie dokie finance company. Well, I'll do a little squiggly end of review thing here. So, Okie dokie finance company advanced 3 loans to D. $2,200 on June 23rd, $1,800 on August 5th, and $1,300 on October 31st. It doesn't tell us the year, so we can just pick a year and go with it. Okay. Simple interest at 7.25% was charged on all 3 loans, and all were repaid on December 31st when some bonds that she owed matured. It doesn't matter why, but whatever. What total amount was required to pay off the loan, right? So we all know how loans work, right? We get a loan, we get that amount, but then to pay it back, we have to pay back that amount plus interest, right? And so here the interest is going to be 7.25% per year. What you'll notice with these problems is there's going to be lots of time points, right, that we have to kind of keep track of. And so what we're going to start doing is we're going to start building timelines for just organizing this information. Okay? And so we'll start by building a timeline. So just kind of fill up your page. You'll want as much space as you can. Okay. And then what you want to do is you want to figure out how many dates do you need to put on there, right? And so first thing I would go through and do, and so there was a loan on June 23rd, and then August 5th, and then October 31st, and then don't forget about the date that they were all repaid on December 31st, right? So just looking at how many dates there were, right? There's 4 dates that we need to map on this timeline. So we need 4 kind of ticks. So the first 2 we've got, so now we just put 2, and it doesn't matter where on the timeline they go, because it's just to visualize how things are moving. And so I'll make the list of the steps later, because we'll be building a lot of timelines. We'll want to follow these steps always, right? So first step is just figuring out how many dates you have, making those ticks, and then putting those dates above those ticks. Okay, so we're going to put the dates up above. And so we've got June 23rd. So here we've got June 23rd. The second date is August 5th. Third date is October 31st. And then they're all repaid on December 31st. So once you have those ticks lined up, right, what we're going to do is we're going to put the dollar amount, right, below it. So up above you've got the date, and then below you've got the amount. So we've got 2,200 on June 23rd, 1,800 on August 5th, and 1,300 on October 31st. There's no amount on December 31st, but we want to know what total amount was required to pay off the loan. So the reason we map this out this way is because, well, this 2,200, we have to pay interest, right, from June 23rd all the way to December 31st, right? And so same idea, 1,800, we have to pay interest on that from August 5th, which is a little bit shorter, right, to December 31st, right? And so we have to repay all of these individually with interest. So to indicate that, what we're going to do is we're going to draw arrows, because we need to force all these amounts to go forward to a future value, right? So if you're moving this way, you're calculating a future value. These are your present values. Okay? And so all these are going to have individual arrows, right, going to December 31st. And what I like to do, because I don't imagine if you start and draw this line first, and then you draw this line, then they're just kind of overlapping. To avoid that, and the only reason I do it is to avoid it, is I'm going to start with the one that's closest, and then draw the arrows from the one that's closest. But that's really just a matter of, that's how I like it, because I don't like all my lines crisscrossing. Okay. Let's show you what I mean. So here, we're going to take this value. Hey, you were in the party in the student, what was that?
It was accounting club.
Oh, cool.
Social.
Fun. Oh, cool. Is it over? Or are you skipping it? Oh, okay. Oh, no, I was going to say go back to the party. You're welcome to stay, but I'd go back to the party. So I'm going to draw these arrows just from the most recent, just because I'll show you here. right? That way my arrows don't overlap, and that's the only reason. Okay. So we have to pull all these forward, right, to figure out, well, what is this 1,300 worth on December 31st, right? How much do we have to repay? And so to indicate that we have to calculate this amount, I'm just going to write FB, but because we're going to have FB1, FB2, FB3, it's best that you just indicate those with maybe a subscript. Okay, so what I'm going to do is I'm going to have FB1, and the subscript doesn't matter, right? It's just to say, hey, here's the future value of the 1,300 from October 31st. And then FB2, and then FB3. Once we know those individual amounts, right, then we can calculate, didn't give myself a lot of room here, the total owing. Sorry, it's hard to write. So we need to put, because the length of each arrow is time, right? And in our calculation, if you go back up to our formula, right? Our formula, now we want to solve for a future value. Right? And so we know each of the present values, the principal amounts, are just the original loan amounts. Right? And then one is just one, and then the rate we know is 7.25%, and time is the length of each arrow, right? And so that's what's going to change for each of them. Okay. So what we do is, well, we're going to put the time on each arrow, right? So we're going to have T subscript 1 is something, T subscript 2 is something, and T subscript 3 is something, right? Just matching up future value 1 with T1, future value 2 with T2, etc. Luckily, we learned how to calculate days between dates on our calculator, right? So then we can find the number of days between each of these dates, right? And that's how we're going to get our time. So find T1. So the notation we use, right, is DT1, DT2, and days between dates. And I'm going to put a star next to it because that's the one I'm going to solve for. Remember, the format is month, month, dot, day, day, year, year. And so date 1 for T1 is October 31st. Right? So you want to make sure that you're using the right date for each T. So October is September, October, the 10th month? Yeah. 10.31. And then, I don't know, let's use this year, 19. I'll make a note here though. Using this year, since it's not specified. As long as we use the same year for each of these, we'll be fine. So then date 2 is going to be the same for all of them, right? So that makes it almost easier to plug it into your calculator than it does to write it all down. And if you wanted to just go straight into plugging it into your calculator, that's fine. But the date is 12.3119. So to use the days between dates on our calculator, just as a refresher, you're going to go to the second date function, which is the number 1 button, and then 10.3119, enter. Scroll down, 12.3119, enter. Scroll down, compute, right? Once you're on days between dates, hit the compute button, the CPT, and you should find 61 days. Okay. Everyone on board? No? Kind of. I'll assume y'all are. So we've got 61. T is always in years, right? So 61 divided by 365. Okay. How about if we have to find T2? Remember, date 1, date 2, days between dates. It's the one we're calculating. Date 2 stays the same, so it's just going to be 12.3119. Right, nothing changes there. You can actually just scroll past it. As long as you're changing date 1, you can go back to days between dates and recompute. So for T2, we're going from August 5th. Right? So August is 08, 05, 19. 08.0519, enter. Make sure date 2 is okay, it is, and then days between dates compute, I get 148. So here I'm gonna say 148 divided by 365. Finally, find T3. Same thing, date 1, date 2, days between dates. It's the one we're calculating. Date 1 is June 23rd. So 06.2319. Date 2 stays the same, 12.3119. And 06.2319, enter. Compute. I got 191. $191 out of 365. Okay. And just because the last piece of information that we don't have on our timeline anywhere is the rate, right? So we can just jot it down. The rate is 0.0725. I think that's, yeah. So now what we're going to do is we're just going to work through, calculate each of these individual future values, right? Because now we know the present value, the principal amount, P. Right? We know T for each of them, and we know the rate stays the same for all of them. So now we're going to calculate each of these future values. Future value 1 is P times 1 plus R times T. Future value 1, and this is where I get tripped up sometimes, is because I've drawn the arrow from the most recent one, right? Future value 1 actually has a present value of 1300 and time of 61 over 365. So you want to keep that in mind. So P is 1300 times 1 plus 0.0725. And then T was 61 over 365. So now I'll just go ahead and just compute it, get to the last answer. You don't have to show your middle steps here. So 61 divided by 365, but you'll want to make sure you get the same answer, right? Times 0.0725 plus 1 times 1300. I get 1,315.75137. I'll say, so the future value is money, right? So the future value is the amount, an amount owing, so it's money. So we need 2 decimal places, 0.75. Do the same thing for future value 2, P times 1 plus RT. Future value 2 had a principal amount of 1,848 days. 18 times 1 plus 0.0725. Oops. What did we say? 148 days. 148 over 365. We got 148 divided by 365 times 0.0725 plus 1 times 1800 is 1,852.91568. Oops. Which is 1852.92. Finally, we can find future value 3 the exact same way, P times 1 plus RT. P here is 2,200 and 191 days. So 22, 1 plus 0.0725, 191 over 365. 191 over 365 times 0.0725 plus 1 times 2,200. 2,283.464384. 2283.46. So now the total owing, right, is the sum of these, future value 1 plus future value 2 plus future value 3. So the total owing is future value 1 plus future value 2 plus future value 3. 1575 plus 1852.92 plus 2283.46, which I've got pre-baked here, 5,452.13. So that's our first stab at a bigger timeline, right? But we'll do lots and lots of these and kind of get more comfortable. Any questions about that one? No? Okay. So last day, right, we were talking about, okay, solving for the future value, solving for P, and then like I said, we're going to work our way through. So now we're going to solve for R, do an example solving for R, and then solving for T, do an example solving for T. So solving for R. I think I was highlighting them maybe. I don't know. We have the future value is P times 1 plus RT. So in general, if we had to solve this for R, right, we'd have to divide both sides by p, so we get future value over p is 1 plus RT, right? If I'm not multiplying anything, right, by p, or the 1 plus RT isn't being multiplied by p anymore, I can drop those brackets. And then I can subtract 1 from both sides, so then I get the future value over p minus 1 is r times t. Solving for r, we get the future value, oh, I'll write it kind of sneaky, the future value over p minus 1 all over t. For me, at least, it would make more sense to just have the original equation, plug things in, and then solve for it. Right? Then you don't get this nasty fraction in a fraction. Right? Let's do an example. We'll do example 148, which I had to go back and pick up. So you invested $5,500 1 year ago. Okay? Today, it has grown to a total value of $5,733.75. What rate of simple interest did you have for this investment? Fair enough. Let's see. So we've been given, 5,500. We've been given P is 5,500. And the future value is 5,733.75. And T, it's a little sneaky, right? But it was 1 year ago. So T is just 1 year. Okay. With this information that we've been given, what I'm going to start doing is I'm going to start just building a timeline, right? Even with something simple like this, it might make more sense to just plot out the information that we've been given in a timeline. Okay. So, or using a timeline, right, we've got a start and an end point. There's really only a year ago and then today. So 1 year ago and today. And picking out what dates are involved can be tricky, right? So it's just going to take a little bit of practice to read the problem and figure out what dates are in there, right? But you invested this amount a year ago, so you'll want to put that on your timeline. And then today, right? How much is it worth today? So dates on top, amounts on the bottom. And so you invested 5,500 a year ago, and over that year, it grew to an amount of 5,733.75, and T is just 1 year. So even though it's a really kind of simple timeline, right, it's outlining the same information that we do here. So what I'm going to start doing is just move towards just doing a timeline instead. Okay. So we want to find R. So we've got the future value is P times 1 plus R times T. We could use the formula that we just derived, but like I said, I actually prefer to just use the original formula, plug things in, solve for R. Okay. So the future value is 5,733.75. P is 5,500 times 1 plus R, which is what we're trying to solve for, times 1 times 1. So if we divide both sides by 5,500, we get 733.75 divided by 5,500. You get 1.0425 is 1 plus R. R times 1 is just R. So then if I subtract 1, I get R is 0.0425. What rate of simple interest did you have for this investment? 0.0425 or 4.25%. Any questions about that one? No. Okay. So let's do the same thing solving for time. It's going to be, in general, we're going to follow the same steps, right? Because it's just at this point we'll solve for t instead of r, right? But let's just do it again for practice. Solving for t. Future value is p times 1 plus r times t. Divide both sides by p. Oops. Future value divided by p is 1 plus r times t. Subtract 1 from both sides, so we've got the future value over p minus 1 is rt. So t must be future value divided by p minus 1 over r. Same structure, just solving for the other variable. Okay. Let's do example 155 because it's a little bit more involved and a little bit more fun. And also, it's so kind of a weird question. So Janet borrowed $15,000 from the Bank of Wayne on November 5th, 2001 for a new necklace. I guess a really nice necklace. The Bank of Wayne charges 7.45% simple interest. Interest accumulated amounted to $1,534.67. On what date was the loan repaid? So now we want to know not just how long did it take, right, but on what date if we're working from November 5th, 2001. Okay? So like I said, I'm going to start mapping this out as a timeline just to get a handle on all the information that we've been given. So we'll start here at timeline. There's really just a start and an end point. Okay. So she borrowed some money on November 5th, 2001. And we want to know, when did she repay it? So we can just put a question mark up there. The amount that she borrowed is $15,000. So that's your P, right? There's two ways that we could go about doing this. Because we're given the amount of interest she has to pay, right? We could use the I equals PRT formula, right? Or we could say, well, then on whatever date this is, she has to pay $15,000 plus $1,534.67, right? And that's your future value. I think I'll go that route just because I want to show the future value formula. Right? And so here, she had to pay 15,000 plus 1,534.67. So she had to pay 16,534.67. So in terms of drawing this arrow, right, the 15,000 is going to have an arrow to the 16,000, right? Because the arrow goes from a present value to a future value. So we've got this here, there. We know the rate, we can just jot it down kind of anywhere. The rate is 0.0745, and we don't know time. Right? So what we're finding here is that we have to first solve for time, and then we can find the date, right? Because we need to know how many days is it in order to use the days between dates on our calculator. So, looks like this. So we've got the future value is P times 1 plus RT. So the future value is 16,534.67. P is the 15,000 times 1 plus R, which is 0.0745, and T is the one we're trying to solve for. So we're going to divide both sides by 15,000. So we've got 16,534.67 divided by 15,000. Just as a little stopping point here, I'll do 1.102311333 is 1 plus 0.0745 t. Subtract 1 from both sides. We get 0.102311333 is 0.0745 t. Solving for t, we can divide both sides by 0.0745 divided by 0.0745. T is 1.373306488 years. Right? T is always in years. To use the days between dates function, we need to know, okay, well, 1.3733 years, how many days is that? So to use days between dates, we need to know how many days are in 1.373306488 years. We can multiply by 365. So T is 1.373306488 times 365. Days. I get 501.256868. I guess this isn't really time. Time is always in years, right? But let's say days. It doesn't matter if you set time. Okay. This means it would take 501.26 days. 501 days, we're not quite at that future value amount that we need, right? So we would have to go for 502 days, right, to reach that amount. And so we need to round up we need to round up to the nearest whole value. So we have 502 days. So we can say DBD is 502. So what we know now is that from November 5th and then 502 days later is when she repaid and had to repay this amount of this amount in interest. Right. So here we can say, well, we just calculated this, 502 days. You don't have to put it on there, but nice to have it all. So now we can use date 1, date 2, and days between dates. This is the first time, I think, that we're solving for something other than the days between dates, right? But it works the same way. So date 1 we know is, where was it? November 5th. November is 11/05/01. I'll just make a note here, November 5th, 2001. Date 2 is the one we're trying to solve for, so that's where I'll put my star. And then the days between dates, I'm going to force it to be 502. So date function 11/05/01, enter. 502 for my days between dates, enter, and then scroll up to date 2 and compute. Looks like March 22nd, 2003. A sunny March 22nd morning, she decided to repay her loan for a presumably pretty big necklace. Hopefully. Any questions about that one? No? So. Oh, it even tells you it was a Saturday. Even better. So no questions about that one. Let's get into 4.6. 4.6 is on equivalent payments. Equivalent payments is a scenario like, oh, I'm gonna pay you back $100 in a month, and then I'll pay you back $200 in 3 months. But then I changed my mind. This is kind of a classic setup. I changed my mind and I want to make one payment, I don't know, 4 months from now. Right? What would be the equivalent payment, right? Because I've already committed to paying you these two amounts on these dates. And so now I need to figure out what single amount would be that equivalent payment. We already did it. Okay. Because this big one that we did, I guess it was a while ago, here, she borrowed these ones, and then the total owing is just an equivalent amount. Right? And so we're just going to keep doing the same thing, but the idea is that we're just kind of restructuring loans. Okay. Equivalent payments. So let's do a quick little definition. Equivalent payments are two payments that enable you to end up at the same dollar amount, at a later date. While we're at it, we'll define payment stream and focal date, just because it's terminology that I might throw around. So a payment stream is a series of two or more payments, required by a single transaction or contract. Payments required by a single transaction or contract. For example, I borrow $500 from you and then I commit to paying it back, in a month from now, right? That would be a payment stream. Okay. Or I'll break it up into two payments because I can't handle it, right? So it's a payment stream. We'll also talk about a focal date. The focal date is just a date of importance. And importance, I mean, I'll just put in brackets, to our calculations. Oops. To our calculations. Right. On timelines, our arrows get drawn to the focal date. So on timelines, the arrows will be drawn to the focal date. Okay. Let's do example 159. So, a particular investment pays $800 payments for 8 and 12 months from now. Okay, so the idea is you go to the bank and they say, well, if you give us this amount, we'll give you $800 for 8 and 12 months from now. Right? And so question is, what is the most an investor should be willing to pay for this investment today if money earns a rate of return of 6%? Use today as the focal date. So what we've got in terms of a timeline, right? We've got today. That's an important one. So today, and then we've got payments at 4, 8, and 12 months. So we've got 4 payments. So we're going to start drawing our timeline with 4. I'll put them out equally, even if they're not. In this case, they are, but sometimes they're not. So I'll just start with today, and then I've got 4 months, 8 months. I'll just do M and 12M. Get lazy. Okay. So if we get $800 at 4 months, at 8 months, and at 12 months, all these values are going to get drawn back to some value today. Think about this though. The value of this 800 today, that's going to be slightly less, right, than 800. Each of these are going to be a little bit less, right, because they've already, in theory, they've grown to 800, right? So just when you're doing your work and you want to check your work, right, make sure that the value on this side of the timeline is less than the value on this side of the timeline, right? Because it'll always grow regardless of whether you took out a loan, right, or you invested some money. So drawing these arrows back, and again, just kind of starting with the one closest to today in this case, because we want to pull them back to today to see, well, what are these things worth today? Just make a little note here that today is our focal date. And as you'll see, right, all these arrows are going to the focal date. These arrows are going backwards, right? So they're going to some present value, P. So we've got P1, P2, and P3, same type of scenario, right? Just kind of finding present values instead of future values. The sum of all these is the total value of the investment today. Let's put the time on these arrows, right? So we've got T1 is 4 months. There's 12 months in a year, so 4 out of 12. T2 is 8 months, so 8 out of 12. So you'll want to be careful when you look at these arrows, right? It's the length of the arrow. T3 is 12 out of 12. And rate is 0.06. I can already see that I need to find P 3 times, right? So it might be useful to just solve for P once, and then I can just use that formula, right? So we've got the future value is P times 1 plus RT. Solving for P, right, we've got P is the future value over 1 plus RT. Now that I've shown that, I can use it in my work. So now I can solve for P1. P1, all of these have a future value of 800. So we've got 800 over 1 plus R, which is 0.06. And T for P1 is 4/12, so 4 out of 12. Only because I've got them written down here. 800 over 1.02 is 784.31. Use my ready-made answers. Save us a little bit of time. Not a lot though. P2 is 800 over 1 plus 0.06 times 8/12. The only thing you need to be careful with is that you match the time with each of the P's, right? That's the only sneaky part, which is 800 over 1.04, which is 769.23. P3 is 800 over 1 plus 0.06, times 12 over 12. 800 over 1.06, 754.72. So the total value, right, of this investment today is P1 plus P2 plus P3, which is 784.31 plus 769.23 plus 754.72, which is $2,308.26. That's the most you should be willing to spend on this, right? Because if the bank is offering 6%, then if it's going to cost you $2,400, right, to get 800 in 4 months and 8 months and 12 months, you could just take this amount and invest it and get the same situation, right? And so unless it costs less than that, right, you're not interested. And so the investment must cost less than $2,308.26. I don't know, to be of interest. No, that's not a good word. I'll just end it there. Not creative enough tonight. What we were doing here, because notice that each of these values, right, looking at P1 has a present value of 784.31. So 784.31 here, if it sits there at 6% for 4 months, it'll grow to 800. Right? And so working backwards, when we're taking this 800 and turning it into a P, what we're doing is discounting, right? We're calculating the present value, so we're discounting. So I'll just make a note here. Discounting is the process of calculating a payment's present value. See if we want to do this one. We want to go. Let's do example 163, because it's a little, I was gonna do 161. It's in the textbook, so you can just look it up, but let's do 163 together just because it's a little bit more involved. 163. So here's kind of a classic scenario, right? And so a lot of these questions that we have to do will take this form, I guess. So 4 months ago, Teresa borrowed $1,000 from Josh and agreed to repay the loan in 2 payments to be made 5 and 10 months after the date of the agreement. Okay, fair enough. So she borrowed some money. She's going to pay it back in 5 and 10 months. Each payment is to consist of $500 of principal and the interest at the rate of 9% on that $500 from the date of the agreement, right? And so because she's paying $500 plus interest at different time points, right? There's going to be a different amount of interest. Today, so now she's like, uh-oh, I changed my mind. Today, Teresa is asking Josh to accept a single payment 3 months from now to settle the debt. Right. So she was meant to make all these 2 repayments, but then she's saying, I'm just going to make 1 payment at a different date. Okay, how much do I owe you? And so, what payment? What payment should Josh require if money can now earn 7%? Right. So now the interest rate has changed for this restructured loan. Okay. And so you could probably tell how important it is to map out the timeline for this type of problem, right? We need to kind of figure out where things are going. Okay. And so we're talking about, so first thing we're going to do is just figure out what dates do we need on here. So we're talking about 4 months ago. That has to be a tick. And she's going to make payments 5 and 10 months after 4 months ago. Right? Each payment is to consist blah, blah, blah. And today, so we'll put a tick on for today. She wants to make a payment 3 months from now. Right? So without doing any math, I'm going to guess there's 5 ticks on there. Right? Some of those could coincide, but probably not. And so what we're going to do, we're just going to start plotting 5 ticks on here. So 1, 2, oh. Need them a little bit closer. It's hard to put 5 on there. I'll start with the first tick because that one I know. So 4 months ago. Right. That's 4 months ago from today, right? So this tick must be today. Here, it gets a little bit trickier, right? Because, well, she was going to make payments 5 and 10 months after 4 months ago, right? And so 4 months ago, 5 months is the next tick, but that's only 1 month from today, right? And so it just depends on how you want to map this out, right? Whether you want to talk about, okay, well, from this point in time, right, I'm going to talk about the distance, but we have to be all on the same playing field, right? And so what I'm going to do is I'm going to change this 5 months from 4 months ago into 1 month from today, because I find it easier to talk about in terms of today, right? 1 month from today. I guess 6 months from today, right? But up above a little bit higher here, I'm going to say 5 months from agreement is really just 1 month from today. Here we have to start kind of figuring out, okay, which is going to come first? 10 months from 4 months ago, that's 6 months from today, right? Or she wants to make a single payment 3 months from now, right? So we've actually got the 3 months from now and then the 6 months from today. So we've got 3 months, and then here we've got 10 months from agreement, which is actually 6 months from today. That's hard, right? That's going to take some practice, kind of reading these questions and figuring out, okay, what goes where and why, right? But that's why I wanted to do this one together. What they're trying to say here is, okay, so she borrowed $1,000. She has to pay back $1,000. But what she wants to do is she wants to split that 1,000 into 500 and 500 and repay them at different time points. And so what we've got is 4 months ago, she borrowed 500 and 500, which is 1,000 total borrowed. The original plan was that she was going to repay this one 5 months from the agreement date, so 1 month from today. So that would be some future value 1. And she was going to repay this amount 10 months from the agreement date, 6 months from now, some future value 2. Okay. So that was the original. Okay. I'll use a different color maybe. Green. I know it doesn't show up that well on here, but in the PDF it will. So now, what we want to do is we want to figure out, okay, so she's not going to make those payments anymore. Now she just wants to make a lump sum payment at 3 months from today, which means that this amount has to get pulled forward, right? We have to borrow it for a little bit longer. And I'll denote that by a future value 3. Right? Because if she's not paying it back a month from now, she's paying it back in 3 months, well, she has to pay more interest on that, right? So it's going to become a new future value. Right? And then this second payment, she's paying back sooner than expected, right? So she's actually going to have to pay less interest on it. Right? So if we pull this back, that's going to become some P subscript 4. I'm using the subscripts just to denote the order of my calculations. Future value 3 and present value 4, that's the total owing, right? Single payment at 3 months from now. So this is the total owing. Three months from today. Okay. We'll put the time on each of these arrows. Right, so the time, we've got T1. If you just do T, it's okay. The time between 4 months ago and 1 month from today is 5 months, right? Because it was 5 months from the agreement date. So the length of this arrow is 5 months, so 5 out of 12. The length of the second arrow is 10 months, so 10 out of 12. What I'm also going to do, because this interest rate went from 9% to 7%, on these two original arrows, I'm going to say the rate is 0.09. And then on these new arrows, I'm going to make a note below and say the rate is 0.07. Now that we have these two different interest rates to deal with, right, we'll want to have them on our timeline just to keep track of which is which. The time from future value 1 to future value 3 is the time between 1 month and 3 months. So that's just 2 months. So T3 is 2/12. T4, the distance between 3 months and 6 months, is 3 months. So 3/12. Okay. To calculate future value 3 and present value 4, right, that's the end goal. We first have to find future value 1 and future value 2, and then we can work those, right, to future value 3 and present value 4. Oops. So first we're going to find future value 1 is P times 1 plus RT. P is 500 times 1 plus R, which is 0.09, times T, which is 5/12. I've got them here, so I'll just 5/1875. And future value 2, same thing, P times 1 plus RT. P is, again, 500. It's just we're charged interest on it for longer. So 1 plus 0.09 times 10/12. Is 537.50. To solve for future value 3, right, we're using future value 1 as our present value. Right? So to solve for future value 3, we need to use future value 1 as our present value. Right, and so amounts can go from being a future value, right? It just depends on where they are on the arrow, right? If they're on the left-hand side of the arrow, they've turned into a present value. If they're on the right-hand side of the arrow, they're a future value. So future value 3 is P times 1 plus RT, where P is 518.75 times 1 plus R, which is 0.07 now, times 2/12. Don't know why I went to do that. I have here 524.80. Same thing. To solve for P4, we need to use future value 2 as our future value. That's not so weird because we're working in the same direction. So present value 4 is the future value over 1 plus r times t. I'm using that because we solved for it once already. Future value 2 was 537.50 divided by 1 plus 0.07 times 3 over 12 is 528.26. So then the total owing three months from today is future value 3 plus present value 4. Right? They've taken into account future value 1 and 2 and merged them back, which is 524.80 plus 528.26. So the single payment that she would pay is 1,053.06. Any questions about that one? No? Okay. We're just going to do one more example. The reason I want to squeeze it in is because it's a different type of problem. So it's where we're going to solve for the payment amounts. So we're going to do example 165. Okay. So a loan of $10,000 requires 3 equal payments to repay the debt. We don't know what those equal payments are, right? But we're going to find out. The first payment is after 6 months, the second after 1 year, and the third after 1.5 years. Fair enough. What is the amount of the payments? Remembering that the payments have to be equal. Use today as the focal date and assume a rate of interest of 6%. So let's just map this out and see what we've got. So we've got today, right? Because we're talking about 6 months, 1 year, and 1.5 years. Presumably they're just from today. Right? So we'll start today. And then we've got 6 months, 1 year, and 1.5 years. We don't know the payment amounts, but that's what we're trying to solve for, right? So typically, whatever we're trying to solve for, we just use an X, right? And so what I'm going to do is I'm just going to use x, 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 because as long as I use the same values, right? X is the same as X is the same as X. And that's what's going to make sure that I have the same equal payments. And so what we've got is that X, this first X is going to map back to some present value 1. Second X is going to map back to some present value 2. And third X, same deal, present value 3. Remembering that these are all paying off a loan for $10,000. Why can't we just take 10,000 and divide it by 3 and be done with it? Well, because this amount is going to be worth less here than this amount. Or is it vice versa? Thinking is not 100% today, so we'll see. Okay. So using the X there, right, we'll be able to ensure that we have these equal payments. And so here we'll have T. The amount of time on this first arrow is 6 months, so 6 out of 12. Second arrow, we've got T is 1, and here we've got T is 1.5. So those aren't bad. Okay, so what we're going to do is we're going to go ahead and solve for P1, P2, and P3 with X in there. Right? And then, because what we know is that P1 plus P2 plus P3 has to equal 10,000. Right? So we can just keep X in there and then use the fact that they have to add to 10,000. I'll just jot down the rate is 0.06. I guess I'll add on here that this is the focal date. As long as you're drawing your arrows to today, that's your focal date. So what's this going to look like? P1 is the future value over 1 plus RT. The future value of P1 is just X. X over 1 plus 0.06 times 6 over 12. 6 over 12 times 0.06 plus 1. So this is X over 1.03. Another way we could write this, right, because we have to add these up and adding fractions isn't that fun, right? We have to find a common denominator. What we can just do is we can rewrite this as 1 over 1.03 times X. That's the same. And then you've got this 1 over X button on your calculator. It's under the PMT button. And that'll just take the inverse of it, right? So it'll just take, so you've got 1.03 on your screen. And then if you hit the 1 over X, that is 1 over 1.03. So what you can do is you can rewrite that as 0.970873786X. Because it's going to be important that you keep all those decimal places, I would just store it. I'll store it in 1. Make a little note to myself. Okay. So now we know that P1 is this 0.97087 whatever times X. Okay. Now we'll do the same thing for P2. P2 is X over 1 plus 0.06 times 1. which is x over 1.06, which is the same as 1.06, 1 over that, 0.943396226 times x. I'll store that in 2. Same thing for P3. P3 is x over 1 plus 0.06 times 1.5, which is x over 1.09. 1.09, 1 over that is 0.917431193x. I'll store that in 3 just in case. Because we know the total borrowed was 10,000, we know that 10,000 must be P1 plus P2 plus P3. Right? So even though these are still in terms of x, right, we can still work with them. P1 was 0.970873786x plus P2, which was 0.943396226x plus P3, which was 0.917431193x. We know how to, so we've got x, x, and x. We can collect like terms by just adding up the coefficients. And so we get 2.8317012005x. This is all equal to 10,000 all along here. Solving for x, we get x is 10,000 divided by 2.8317012005. So x must be 3,531.45. So thinking about our timeline, 3,531 here gets mapped back. 3,531 here gets mapped back. 3,531 here gets mapped back. And so they're all repaying slightly different amounts of this 10,000, right? But together they're going to make 10,000. Yeah. Any questions about that? No? I'd say that's plenty for tonight. And I guess it's reading break time. Sort of. It's only Wednesday, I know. But for me it is. And my throat can't wait. So I'll just scroll up in case anyone's working that out. But otherwise, have a great break, guys. You guys, I'll post the Moodle quiz. But it'll be due after the break anyways. So don't worry about it. Oh. Anyone copying stuff?